Okay, this is lesson for day 127, composition of functions. So we're going to go back to the idea of functions in math. So functions in math are math machines. Okay, you put ingredients in and things pop out, okay, right? So if I get masa and some carne asada and some tomatoes and onions and cilantro and maybe some jalapenos, and I put it into this machine, a little salt and pepper and tapatio, and then start bloop, 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 and then what pops out the other end? A burrito! Yes, that's right, a burrito, okay?
Did you put beef in there?
It's a carne asada burrito, okay? Okay. Did you get the point, though? You put ingredients in and what pops out?
A burrito.
A burrito, okay? What's wrong?
No side conversation.
Okay, so masa is like to make tortillas, right? The masa. That's good when it's fresh. Who knows about fresh tortillas? Oh, so good. Masa. Okay. Or when you go to Disneyland and you see the tortilla factory. Maseca.
It's not there anymore.
Remember though?
Yes, I do.
Okay. Okay. So in math, we got the same idea here. This is the machine in math, okay? This is the machine in math. H of x. If I were to put, and it's saying h of x, the machine, this is what it does. It takes numbers and it squares them first, and then it's going to add 3 times the number, okay? So, it's asking what happens if you put -6 in this machine. Well, what's -6 squared, everyone?
36.
36, that's right. And then what's positive 3 times -6? So what's 36 minus 18? What's 36 minus 18?
18.
18, right? That's the answer. That's what's going to pop out, okay? Does that make sense? Okay, cool. So, today, we're going to build on that idea. Let's say I had 2 machines, okay? Okay, let's say, and you have these 2 machines, and you're like, I'm going to put ingredients into the first machine, and I'm going to put more ingredients in the second machine. So, I put in the masa, and I put in carne asada, and tomatoes, and onions, and jalapeno, salt, and pepper, tapatio, and just go bloop, 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 and then what pops out? A burrito, right? And then I take the burrito, and I'm going to put it into the second machine, okay? And then I'm also going to put in, a napkin, and some cardboard, and a horchata, and then what pops out? My lunch, okay? Does that make sense? A perfect lunchbox. Does that make sense?
What's on the lunchbox?
Whatever you like, okay? But the idea here. Okay, so here are the steps that are that we're going to be working on today. So take a moment and copy those down if you're on the video. Please pause here. On step 2, you'll see the word precedent. It just means the one that's before. It's the one that comes before. Evaluate the function that comes before or precedent function with the secondary function, okay? That'll make sense, right? Just like when I just made my lunch for today, what did I have to do first in the first machine? Make the actual box lunch or the burrito? I made the burrito first. Does that make sense? So we have a process, we have a procedure we have to go through, okay? Okay? All right, so here we go. We know the answer to that, so we're going to move on. Okay, numbers 1 and 2, eyes up here. Okay, so the functions can be used differently. I could add functions together just like I made my box lunch for today. I had to do the burrito process, and then I had to pack the lunch process, that machine, right? Sometimes that was adding. Sometimes we might want to subtract. Sometimes we want to multiply or divide. Sometimes we're going to put one function into the other, like we're going to put one machine into the other so it does both jobs at once, okay? So number 1, there's 2 functions here. We have g of n, which gives us a rule. It's equal to 4n minus 2. And then I got a second rule, h of n, which is 4n minus 4. And it's saying, hey, check this out. I want you to find g over h and use the variable n as your input, okay? Meaning, take your first function, g of n, and divide h of n from it, okay? So all I'm doing here is I'm saying g of n, what is g of n divided by h of n? That's what it's asking me, okay? So I'm going to take g of n, which is 4n minus 2. That's going to be in my numerator. And then my denominator is 4n minus 4, because that's what my h of n is. Y'all see that? So I'm just substituting. And then I'm going to try to solve this or evaluate as much as I can. So now this is a rational expression, just like we've been working on. I'm going to look at the numerator. I'm like, hey, I wonder if I could simplify this at all. Can I factor anything out of the numerator? Yeah, I could factor out a 2. This is like saying 2 times 2n minus 1. And the denominator, I could factor out a 4, which is 4 times n minus 1. And then I'm like, hey, I could simplify this. 2 goes into both 2 and 4. So we could, we know 2 goes into 2 once and 4 twice. And I could rewrite this 1 times 2n minus 1 as 2n minus 1, all over 2 times n minus 1. And then, of course, I know about excluded values. Now, what can the denominator, or what can n not equal to in this problem? Good, 1. What happens when n is 1? What's 1 minus 1? 0. And then once that denominator is being multiplied by 0, we get undefined. So we don't want n to be equal to 1. Okay? So that is number 1. Okay? And all I just did is I took 2 machines and I'm dividing one by the other. Okay? And this is a new rule. Okay? Just like when I'm like, hey, I'm making my lunch. The big idea is, or the rule is, I'm trying to get a packaged burrito for lunch today, right? Or this rule, when you combine both of them, you're going to get this when you divide them. Okay, questions on number 1? Okay, number 2 now. We got g of x is equal to 2x minus 2, and f of x is equal to 3x plus 5, okay? And it's saying find g of f of 9, okay? So this gets a little confusing, but just go slowly, okay? We want to think about what's the precedent function, or the precedent function. What's the primary one? Well, the one that comes before the precedent function is g, right? So we're going to take g of x, and we're going to take g of x. But look what I'm going to do. It's not saying just g of x. Instead of g of x, whenever I see x, I want to plug in f of x. So whenever I'm going to take the precedent function of g of x, and I'm going to plug in f of x whenever I see an x. That's what this is asking for. Okay? So check this out. I'm going to take g of x. I'm going to copy it down. Here's my precedent function. G of x is 2x minus 2. Eyes up here. So you got 2x minus 2. And then I notice that whenever there's an x, I'm going to replace it or substitute it with f of x. So what's f of x equal to? 3x plus 5. So you see it's 2 times x, so I'm going to keep the 2. And then I'm going to substitute f of x into there. I'll do that with a different color so you can see that. So I just saw 2x, so I'm replacing it with f of x in here. And then I'm going to bring down to minus 2. Okay? And now I'm just going to evaluate this. 2 times 3x is 6x. 2 times 5 is positive 10. And then we got minus 2 at the end. What's 10 minus 2? 8. So we got 6x plus 8, right? That's when we combine the precedent function with f of x. Now look what happens at the end here. It's saying, hey, but look what x is supposed to be equal to. We want x equal to what? 9. So whenever I see an x, I want to put 9 in. So what's 6? We're going to replace x with 9 now. So we got 6 times 9 plus 8. What's 6 times 9, everyone? 54 plus 8? 62. And that's your answer. Does that make sense? Okay, it'll get easier with practice. It's a little bit confusing. You have to think it's a process, right? How do I make my lunch all day for the day? How do I make my lunch for the day? What do I make first?
Burrito.
The burrito. And then what do I do with the process after?
Box.
The box, right? So same thing here. I'm starting with g of x. I'm plugging in f of x when I see there's an x in g of x. And then at the very end, when I have my actual function, we're going to substitute and evaluate for x. Okay? And that's it. So let's have students, continuing on here, let's do number 3 now. We're going to do number 3, so let's look at number 3 together. We got g of a is equal to 2a minus 5. We got f of a is equal to a squared minus 3. And so it's saying, hey, let's take g of a and subtract f of a. Okay? So, the big idea here, let's do this one together. You're all writing this down. Let's go. The big idea here now, we're thinking, okay, we're going to take g of a. So let's write down g of a. And we're subtracting f of a, okay? That's all you're thinking right now, okay? So now we're going to substitute. What's g of a equal to, everyone? 2a minus 5, okay? And then we're going to subtract the second term, which is this binomial, a squared minus 3. Since I'm subtracting this whole binomial, I'm going to have to put parentheses around it. And put parentheses around the first one, right? I got one binomial subtracted by another binomial, right? Okay. So what's 2a minus, are there any other a's I could subtract from 2a? No, so let's just bring 2a down, okay? Next, negative 5. Is there any constants I could subtract from negative 5? Okay, what's negative 5 minus a negative 3? Negative 2, good, negative 2. And then there's a minus a squared, we got to bring that down. And that's it, this is a positive 2a, right? So that's it. Again, this is an Algebra 1 problem when you're looking at doing adding and subtracting binomials, right? Okay? So, yeah. What we're actually doing when you do functions like this, you're actually just taking big processes and you are programming it, right? If you look at a computer, like a computer program, it might say, hey, when you click this button, I want you to take this function and subtract this function from it, and then you're going to get this. And you would tell the computer how to program it. Okay, so number 4, what are you telling the computer to do on number 4? Multiply, right? We're going to take g of x and multiply it with h of x, right? So you're thinking the big idea. You would tell the computer, hey, take g of x, and you're going to multiply with h of x. Okay, so what's g of x then? What would you tell the computer g of x is equal to? Good, so we do x plus 1 into its own parentheses, and then we're multiplying what's h of x, everyone? X squared minus x, okay? So I'd like you to work this one out by yourselves. If you need to math chat, I'll let you do that. I'll give you 1 minute, okay? Go. Here we go. So the answer is, when you multiply it out, you should get x cubed minus x squared plus x squared minus x. If you got that, that's correct, but you need to finish up the answer by simplifying, so it's x squared minus, or I'm sorry, x cubed minus x is the answer. Does that make sense? If you got it right, give someone a high five around you, if you haven't yet. Okay, good job. If you're the only person, just give yourself a high five. Okay? Over your head. Okay, next one. Sorry, we got to keep going. We're going to jump to number 6 now, because number 5 is like number 6. Okay, so this one's different, right? This one's saying, hey, I want g of f, meaning we have a precedent function, and then we're going to put the secondary function into it. So what function is precedent, g of t or f of t? Or precedent means which one comes before, g of t or f of t?
G of.
Good, so we're going to start with g of t, right? And we wanted, whenever I see a t in g of t, we're going to put an f of t. So what we're going to, you see how there's a t right here? Instead of putting a t here, we're going to replace this t with f of t, which is 3t plus 3. So check this out. I'm going to rewrite it. Bring in down that f of t in there, and just bring the rest of the problem down, okay? Do y'all see that? Okay, so we got the original g of t. Do y'all see that?
No, you're in the way. Wait.
We have a lot of time to be silly. Okay, so we got g of t here, right? And then I got t inside here. It's saying, hey, whenever I see a t in g of t, let's input f of t. There's f of t. I'm putting it in right here.
Wait, what told you to do that?
Right here. It says find g of f. Meaning take the original precedent function, we're going to put f into it.
Oh, is that what
This is the notation. Uh-huh. Yeah. Okay? We're going to do that at the very end. I'll show you. Okay? So, we set up the problem now. Let's simplify. What's 2 times 3t? 6t, okay? And then what's 2 times positive 3?
6.
And then we bring down 4. What's 6 plus 4?
10.
Good. So now we have a rule here that includes the precedent rule with the subsequent f of t in there. Okay. So we got 6t plus 10. Okay. But what is it telling us to do with t? What's the value it wants us to input at the very end? Negative 8. So we're going to put negative 8 in for t. So what's 6 times negative 8?
Negative some.
You got this.
48.
And then negative 48 plus 10 is
-38.
negative 38. And that's it. Okay. Okay, so this one's like number 2.
Hi.
Hi, good morning. Welcome.
I'm in the right place?
Absolutely, welcome. I'm Dave Rinkwood.
Dave?
Pleasure.
It's nice to meet you.
Nice to meet you. I'm just going to wrap with some math class, but do you need the computer or anything?
I have my own Surface. If I could just get some kind of a display so I can display it up here, that'd be great.
Great, okay.
Whatever you need to do, go ahead.